Hi folks, we're going to take a look at number 23 from page 226. So here they want us to find an exact value for A that solves this equation. Okay, given the type of equation, there's probably infinitely many solutions, but I'm just going to see if I can actually find two of them instead of just one. So at this point, you're hopefully starting to recognize that as soon as we have a relationship, or in this case here an equality between two trigonometric ratios, we should be thinking about our correlated angle identities, or our cofunction identities, okay, that relate to different trig ratios. So let's try to figure out which of those we're going to use. So you notice here I don't just memorize them, I try to just, in each case, I try to figure out which ones I should be using. So as a guide, we always start with our theta being in the first quadrant, okay? Whether it is or isn't, we just, again, it's just the picture is just a guide for us to figure out what to use. Okay, so in this case here, secant is equal to a cosecant value. Now, if you don't like thinking about secant and cosecant, you can think of it as when is a cosine value equal to a sine value, because those are just the reciprocals. They're going to have the same signs. Okay, so let's think about when a cosine value is going to be equal to a sine value. Okay, it might be easier to think of it this way. Well, since they have the same sign, and sine is positive here, then the cosine one is going to have to also be in the first quadrant. Okay, so our first one that we're going to be able to use is pi over 2 minus theta. Okay, now where else is cosine also positive? Well, not in the second quadrant, not in the third, but in the fourth quadrant. It's also positive. So the other angle we're going to use is going to be 3 pi over 2 plus theta. So we have that cosine of pi over 2 minus theta is equal to sine theta, and cosine of 3 pi over 2 plus theta is also equal to sine theta. Okay, so these are the two relationships I'm going to use, except instead of cosine equaling sine, it's going to be secant equaling cosecant. Okay, so now let's solve this problem. So if we think of this as being our theta, that means that A has to be equal to pi over 2 minus theta. Pi over 2 minus, in this case here, our theta is 3a, and now we've created a nice easy linear equation to solve for. Bring the minus 3 to the other side, so we get 4a equals pi over 2. A is equal to pi over 8 when we divide 4 to each side. Okay, so there's one answer, and that could be fine for this question here, but let's see how we can find a second answer. All right, in the second option, A now, this angle inside the secant can be equal to 3 pi over 2 plus theta. So 3 pi over 2 plus our theta, which in this case here is 3a. And now again, a nice easy linear equation to solve. So I'll bring the a to this side here, so that gives me 2a. Bring that to the other side, negative 3 pi over 2. So that means a can be equal to negative 3 pi over 4. And there's a second answer that would be valid as a solution for this equation. Okay? Now it does ask us to check our answer, so I'll do it for one of these just so that you see how it could be done. So how does one check an answer to an equation? Well, you just stick it into each side and make sure those sides are equal. Okay, so I'll use the easier one. I'll do this one here, pi over 8. Okay, so if I do the left-hand side, what is the left-hand side equal to? Well, just the secant of pi over 8. So secant is 1 over cosine. So 1 divided by cosine of pi over 8. Make sure your calculator's in radians. Okay, and what do we get? We get 1.082. Okay, and let's check our right-hand side. Our right-hand side is cosecant, so 1 over sine of 3 times pi over 8. 3 times pi over 8. And we see 1.082. And so we see that that does solve the equation. If you did the same thing with negative 3 pi over 4, you should get the same result, that left-hand side is equal to right-hand side. Okay, so let's just do a quick recap. Okay, number one is to recognize that when you have two trig expressions that are equal but are different from each other, so different types of trig ratios, that you should be thinking of your correlated angle identities, so the ones with pi over 2 and 3 pi over 2. The next step is to figure out which ones to use. So since they were actually equal to each other and not negatives of each other, you need to figure out when they're both positive if you assume that theta is in the first quadrant. So in this case here, when is cosine positive? In the first quadrant or in the fourth quadrant. And that led to our choice of these two identities. And then step 3 is to associate the angles in your actual trig ratios to the angles in your identity. So in this case here, this was going to be equal to my pi over 2 minus theta. This was going to be equal to my theta. Okay, that's it for this one.